Welcome to Main 5W channel. In this session, we're going to speak about quantum computing 101 because I had released several videos on quantum computing. We also did an half-a-day workshop on quantum computing, but there were a lot of questions which was related to can we speak quantum computing more from a basic perspective. Okay? So this video is trying to cover some of the base concept. So as usual, when I start any of the session, I would prefer that you refer the Wikipedia as the foundational way to really get a concept right. Okay, because every OEM, every service provider will have some local flavor of what they want to really package. So go to Wikipedia, you're going to have more generic information, so it's always good. So if you really go to Wikipedia of quantum computing, it speaks about what is quantum computing. It uses two important words: superposition and entanglement, to perform computation. So the first thing which you should understand as a layman is basically you'll use the quantum phenomenon and you'll do two things. One is superposition and entanglement. So these are two important words used as terminologies in quantum computing. Okay, and the computers which you use which does this is called quantum computers. So these are the third word which you get: quantum computer which use the quantum computation, and then they use phenomena such as superposition and entanglement. Okay, and why they exist is because they can solve certain problems and which are typically more complex in nature, and you will find that it's actually a subfield of a quantum information science. Okay, it has started in 1980. It continued with a lot of things in 1994. Only in October 2019, when Google AI, in partnership with US National Aeronautics and Space Administration, performed a quantum computer that is infeasible on any classic. So they are trying to show you that there are certain computation which is beyond the capability of a classic computer, which is what quantum computing is supposed to do. So to really see that from a mathematical perspective, it includes the quantum circuit model, Turing machine. If you have really done engineering, you know, like we speak about Turing systems, adiabatic quantum computer, and a one-way quantum computer. And there are various quantum cellular automata which is there basically. Okay, the states is called qubit, similar to the bit. Okay, but in qubits can be in 1 or 0 quantum state. What they also mean is they can be superposition of the 1 and 0 state. Okay, and however, when qubits are measured, the result is always either a 0 or 1. Okay, so like that, there are a lot of things in this Wikipedia. You can just go through it. They're going to talk about what is a quantum circuit, potential applications like cryptography, search problems, basically machine learning, etc. What are some of the kind of drawbacks? What kind of development is happening? Blah blah blah. Okay, so I'll leave you guys to really go through it. So this is a good base to look at. Okay, now let's try to get some answers to some of the questions what is asked to me. So Wikipedia definition is what we really have already seen. Okay, but let's see superposition. There are two terms which are used: quantum superposition and quantum entanglement. Okay, so let's just get a brief. So according to Wikipedia, again it goes back, the quantum state is a mathematical entity. Okay, it's a mathematical entity that provides a probability distribution for the outcomes of each possible measurement on the systems. Okay, so that is how you really look at the quantum things. And you can see the power of this quantum computing is also something of the reasons why you go there. Okay, and the next part, which is basically very important for us, is like a lot of trends happening today, but I will focus on this particular thing on the programming languages and role of open source. So rest of the things you'll get it from the Wikipedia. Okay, so what are the important quantum programming languages? Because I think most of you from an employability will be thinking, how do I relate? There is an infra or a platform which is provided by a cloud vendor or be provided by some of your service providers, right? But what you do is basically you're a consumption and doing something for your customers, right? So first thing you can see is there is something called Q Sharp, right? It's a quantum programming language developed by Microsoft. So that is one thing which you can explore. It's free and open source programming language and licensed under MIT license. Allows us to use qubits in algorithms. Syntax of Q Sharp is very similar to C Sharp, which is again a language from Microsoft, right? Microsoft Q Sharp is a high-level programming language. There is something called OpenQASM, is an assembly language used for quantum programming. Okay? There is an implementation of the OpenQASM in IBM Quantum Experience Quantum Cloud Computing Platform, which is also a free and open source programming language license under the Apache license. CIRQ is a framework for noisy intermediate scale quantum developed by Google. This is also free and open source software license under the Apache license. There is something called CIRQ, okay, uses the Python programming language for developing quantum algorithms. A lot of quantum programming language, but support by Microsoft, IBM, Google make it good. Okay, so you can really search for Q Sharp, OpenQASM, you can search CIRQ. Okay, this will help you to really get started. Okay, after you go through Wikipedia, you'll get answers for definition, what is superposition, entanglement, what is the processing power, what are some of trends and applications, what kind of simulators are there today to really simulate what you're seeing. Okay. The role of open source is also very important because quantum is a field where you need a gigantic budget, right, for hardware search. There are a lot of millions of quantum computers in the world, just like the classic we have today. Every software which is there in quantum computing today is open source. Okay, that's good news for all of us. Okay. So in 2021 or beyond, you can see that there could be a lot more options which are coming in open source. If you really see UNIVAC and ETSAC in 1950, similar to that. Okay, so that's going to be the future of quantum computing, and there are a lot of simulators also which you can really look at, which you can. There is something called quantum cloud services, which is given by IBM Quantum Experience. It allows you to graphically build quantum circuits and develop quantum program using QISKit, an open source quantum software development kit. Okay, so there are so many things. It's an upcoming field, a lot of abstractions, a lot of not understanding. In basic, for a layman, you have to look at your systems computing power today, and you have to look at something coming up in the future. There are some programming language which can really make use of those quantum. That's where this language is, which is coming in. They are the future. So it's good to be aware of it. And you might start making some algorithm. Like we generally saw that in Wikipedia, there were some applications which they're trying to talk about, right? So cryptography, search problems, simulation of quantum systems by using a lot of Haber process, quantum annealing and adiabatic optimizations in machine learning. So all these places you can see that these are going to really get used. Okay, so thanks for watching. A very interesting space for employability, basically for the future. So just start reading as a student now. You will get an opportunity in this down the line. Thanks for watching.